The pilot hovers above the destroyer at 0900 hours on May 3, 1943. Oberleutnant Heinrich Giesler sits in the open cockpit of a Flettner FL-282 Kolibri, the small helicopter rising and falling with the ship's movement as he searches for Allied submarines reported in the area. The Kolibri, hummingbird in German, is the Luftwaffe's answer to reconnaissance problem that has plagued the Kriegsmarine since war began. How to detect submarines beyond visual range from surface ships. Traditional aircraft require airfields. Seaplanes require calm water for takeoff. But the Kolibri requires only a platform 6 meters square on a destroyer's deck, can hover in place while the observer searches with binoculars, and can land back aboard in sea states that would be impossible for conventional aircraft. The helicopter is experimental, one of approximately 30 built. Designed by Anton Flettner using intermeshing rotors that solve control problems that have defeated other helicopter designs. In 2 years, this technology will be too late to matter as Allied dominance makes German naval operations impossible, and as conventional aircraft improve to point where helicopters' advantages are marginal. But today, Giesler demonstrates that helicopters can operate from ships, that vertical flight is practical for military reconnaissance, and that the future of naval aviation includes rotary wing aircraft, even if Germany's contribution to that future will be limited to proving the concept works before the war, and Germany's industrial capacity both collapse. The first mass-produced military helicopter flew combat missions from German destroyers when helicopters were considered experimental curiosities, demonstrating that sometimes being first means pioneering technology that others will perfect, and that innovation during desperate circumstances produces solutions that are technically brilliant but strategically irrelevant, because the war that created the need is already lost. The Flettner FL-282. Kolibri was a helicopter designed specifically for shipboard reconnaissance. The origins trace to Anton Flettner's pre-war work on rotary wing aircraft. Flettner, aeronautical engineer born in 1885, had worked on various aircraft designs through the 1920s and 30s. By the late 30s, he was experimenting with helicopters, attempting to solve the control problems that made early helicopters difficult to fly and dangerous to operate. The fundamental challenge in helicopter design was controlling the aircraft in all 3 axes: pitch, roll, and yaw. Early helicopters used single-main rotor with tail rotor for directional control. This configuration worked but was complex. The tail rotor consumed power, the mechanical linkages were complicated, and the aerodynamics created situations where control was marginal or reversed. Multiple designers, including Igor Sikorsky in America and Heinrich Focke in Germany, were developing single-rotor designs, but Flettner pursued alternative approach. The FL-282 used intermeshing rotors, 2 rotors mounted side by side and angled outward so their blades intermeshed like gears. The configuration was called syncropter or synchronized helicopter. The rotors rotated in opposite directions, canceling torque and eliminating need for tail rotor. Control was achieved by varying the pitch of the rotor blades cyclically, tilting the rotor discs to produce thrust in desired direction. The advantages were mechanical simplicity and efficiency. No tail rotor meant all engine power went to lift and propulsion. The intermeshing rotors provided inherent stability because imbalances in one rotor were compensated by the other. The downside was complexity in the intermeshing mechanism. The rotors had to be precisely synchronized to prevent blades striking each other, requiring robust mechanical system that added weight and maintenance requirements. The FL-282 specifications reflected its role as reconnaissance platform. Rotor diameter, approximately 12 meters for each rotor. Fuselage length, 6.5 meters. Height, 2.2 meters. Empty weight, 760 kilograms. Loaded weight, 1,000 kilogram. Engine, Siemens Halske SH14, a 7-cylinder radial, 140 horsepower. Maximum speed, 150 kilometers per hour. Cruise speed, 120 kilometers per hour. Range, 300 kilometers. Service ceiling, 3,300 meters. Endurance, approximately 2 hours. Crew, 1 pilot and 1 observer in early versions. Single pilot in later production versions. The cockpit was open, providing excellent visibility but exposing crew to weather. The structure was steel tube frame with fabric covering. Lightweight construction that prioritized performance over protection. Armament, none initially. though some later versions carried single 7.92mm machine gun for self-defense. Development began in 1940 under Luftwaffe contract for shipboard reconnaissance helicopter. The requirement specified ability to operate from destroyer decks, hover for extended periods, and land in sea states that would prevent conventional aircraft operations. The FL-282 first flew in 1941 with test flights demonstrating the design met basic requirements. Production authorization came in 1942 with initial order for 15 aircraft. This was modest production run, but represented first mass production of military helicopters anywhere. Previous helicopters had been one-off prototypes or very limited production. The FL-282 was first helicopter designed from the start for military production and operational deployment. The Kriegsmarine was primary customer. German naval forces faced increasing threat from Allied submarines. Detecting submarines required searching large ocean areas, which surface ships could not do effectively. Aircraft could search wider areas but required bases near operational areas. Seaplanes could operate from ships but needed calm water and ship to stop for launch and recovery. Helicopters offered solution: launch from moving ship, hover while searching, land back aboard regardless of sea state. Initial operations began in late 1942 with test deployments to destroyers operating in Mediterranean and Baltic. The helicopters were used for reconnaissance, searching for submarines, spotting for naval gunfire, observing convoy routes. The operations were experimental, testing whether helicopters could operate from ships under combat conditions. The results were mixed. The helicopter could operate from ships successfully. The stability was adequate for hovering while searching. The endurance was sufficient for missions lasting 90 minutes to 2 hours. But several limitations became apparent. The open cockpit was miserable in bad weather. The lack of de-icing equipment made operations dangerous in cold conditions. The maintenance requirements were high. The intermeshing mechanism required precise adjustment, and the exposed structure was vulnerable to saltwater corrosion. More fundamentally, the strategic situation was deteriorating. By 1943, the Kriegsmarine was on defensive. Allied air superiority made surface operations increasingly dangerous. Deploying helicopters required surface ships to remain in threatened areas long enough for helicopter to launch, conduct mission, and recover. This exposure was risky when Allied aircraft could attack German ships with minimal warning. Production continued through 1943 with approximately 30 aircraft completed before bombing of production facilities disrupted manufacturing. Some sources suggest up to 24 were operational at peak deployment. Others suggest lower numbers. Exact figures are uncertain because records were incomplete and some aircraft were lost in accidents or combat. Combat operations demonstrated the helicopter's capabilities and limitations. On the positive side, helicopters could search areas that would require hours for surface ships to cover. They could hover over suspected submarine contacts while ships maneuvered to attack positions. They could observe battle damage and report back immediately. On the negative side, they were slow, vulnerable to fighter attack, limited by weather, and required substantial maintenance support. One documented operation involved FL-282 deployed to cruiser Köln in 1943. The helicopter conducted reconnaissance missions in Baltic Sea, searching for Soviet submarines and monitoring convoy routes. The missions were successful in narrow tactical sense. The helicopter operated, completed searches, and returned aboard. But no submarine contacts resulted in attacks and the strategic value was minimal. The technical achievement was substantial, regardless of operational impact. Flettner had created a helicopter that could operate from ships, that was mechanically reliable enough for military service, and that proved rotary wing aircraft were practical for naval operations. The design influenced post-war helicopter development. The intermeshing rotor concept was adopted by Common in America, producing successful line of helicopters through the 1950s and 60s. But the FL-282's military impact was negligible. The small numbers produced, the limited operational deployment, and the deteriorating strategic situation meant the helicopter could not affect the war's outcome. By 1944, Allied control of seas and air was so complete that German surface ships rarely operated outside protected waters. The reconnaissance role the helicopter was designed for became irrelevant when German ships could not challenge Allied forces. The comparison to Allied helicopter development is instructive. The British experimented with Sierva Autogyros for naval reconnaissance, but did not pursue production. The Americans focused on Sikorsky designs for rescue and observation, but did not deploy helicopters operationally during the war. The Germans were first to produce and deploy military helicopters operationally, but the advantage was temporary and tactically rather than strategically significant. Post-war, Flettner's work was examined by Allied technical intelligence. The intermeshing rotor design was recognized as innovative. Anton Flettner was brought to United States in 1947 under Operation Paperclip, working briefly for American helicopter companies before retiring. His designs influenced American helicopter development, but he did not achieve the same prominence in America that he had held in Germany. The surviving FL-282 helicopters were either destroyed during the war, scrapped afterward, or captured by Allied forces for evaluation. Only 3 complete examples survive today, preserved in museums. One is at Deutsches Museum in Munich. Another is at National Air and Space Museum in Washington. The third is at Polish Aviation Museum in Krakow. These survivors represent the first mass-produced military helicopters, tangible evidence of technology that was advanced for its time but arrived too late to matter. The specifications that made the FL-282 suitable for shipboard operations, compact size, ability to hover, vertical takeoff and landing, became standard for naval helicopters post-war. Modern naval helicopters are larger, more capable, and use different rotor configurations, but they perform the same missions Flettner envisioned: reconnaissance, submarine detection, and shipboard operations. The Kolibri pioneered the concept even if it did not survive to see the concept mature. The question of whether earlier development would have changed outcomes is speculative. If the FL-282 had been available in 1940 instead of 1942, if production had been hundreds instead of 30, if deployment had been to all German surface combatants, would it have affected the Battle of the Atlantic or Mediterranean campaigns? Probably not decisively. The fundamental problems facing German naval forces were Allied numerical superiority, industrial capacity, and air power. Helicopters could improve reconnaissance, but could not overcome these disadvantages. The technology's significance was demonstrating feasibility rather than achieving immediate military effect. The FL-282 proved helicopters could operate from ships, could function in military environment, and could perform useful missions. This proof of concept influenced post-war development by all major navies. Within 10 years of war's end, navies worldwide were deploying helicopters for anti-submarine warfare, search and rescue, and logistics. The lineage traces directly to Flettner's work. The engineering challenges Flettner solved: intermeshing rotor synchronization, shipboard operations, control in adverse conditions, were fundamental problems that had to be addressed before helicopters could become practical military assets. The FL-282 addressed them successfully, providing template that later designers refined and improved. The mechanical complexity of intermeshing rotors meant the design was not widely adopted, but the lessons learned about shipboard helicopter operations were universally applicable. The human aspect of operating these helicopters is documented in fragments. Pilots described the Kolibri as responsive and stable once airborne, but requiring constant attention. The open cockpit was noted universally as uncomfortable, particularly in cold or wet conditions. The visibility was excellent. Critical for reconnaissance missions, the noise was intense, making communication difficult. The vulnerability was obvious. No armor, no significant armament. Slow speed made the helicopter easy target for fighters. No combat losses are definitively documented, though some helicopters were lost to accidents and mechanical failures. The operational tempo was low enough that exposure to enemy action was limited. Most missions were flown in areas where German forces had at least temporary local control. The larger threat was weather and mechanical reliability rather than enemy fire. At 0900 hours on May 3, 1943, Oberleutnant Giesler hovered above the destroyer searching for submarines because the Kriegsmarine needed reconnaissance capability that surface ships alone could not provide. The helicopter gave that capability, but in numbers too small and at time too late to affect strategic outcomes. The mission he flew demonstrated that helicopters worked, that shipboard operations were feasible, and that the technology had military utility. But demonstration was not victory, and feasibility was not sufficient when the broader war was already being lost. The Flettner FL-282 Kolibri, the hummingbird that proved helicopters could operate from ships, represents category of wartime innovation that arrives too late to matter strategically, but influences post-war development fundamentally. The 30 helicopters produced could not change the Battle of the Atlantic, but the technology they pioneered became foundation for naval aviation's rotary wing branch, demonstrating that sometimes being first means proving the concept for others to perfect. The first mass-produced military helicopter flew from German destroyers when the war was already lost, when resources invested in helicopters might have been better spent on submarines or fighters, when the tactical advantages helicopters provided could not overcome strategic disadvantages Germany faced. But the investment was not wasted from longer perspective. The Fel 282 proved what was possible, solved fundamental problems, and created knowledge base that survived Germany's defeat to influence how all navies would approach helicopter operations. The legacy is not the 30 helicopters produced or the missions they flew, but the demonstration that rotary wing aircraft could serve military purposes, that ships could operate aircraft that did not require catapults or arresting gear, and that vertical flight was practical, not theoretical. Anton Flettner's Hummingbird proved these concepts through operational deployment rather than theoretical argument. Flying missions from destroyers while pioneers in other nations were still testing prototypes over airfields. First is not always best and earliest is not always most influential. But the Kolibri's contribution was establishing that helicopters belonged in military inventories, a contribution that mattered more after the war than during it, validated by decades of subsequent development that fulfilled the promise Flettner's small helicopter demonstrated under circumstances where demonstration was all it could achieve.